here to prepare you guys for the stoichiometry percent yield lab. The purpose of this experiment is to get students to be able to calculate the theoretical yield of a combustion reaction, also to calculate the percent yield of their experiment. For this experiment, we're going to need an evaporating dish, a balance, a ruler, a strip of magnesium, some forceps, a burner and a striker, and don't forget our safety glasses. Okay, now when you're performing this combustion reaction, make sure you do not stare at the magnesium strip. It burns very bright and it could burn your retina. Odds of that happening, pretty slim to none, but still, for your safety purposes, don't stare at the burning magnesium strip. All right, okay, so putting on my safety glasses, just as you guys will. Safety first. Okay, first thing we want to do is we want to measure the length of the ribbon of magnesium in centimeters and record it on our data table. So using your ruler and making sure we use the centimeter side, measure the length of your magnesium strip and record it on your data table. Okay, next, using a piece of weighing paper, find the mass of the magnesium using a digital balance. Record this measurement on your data table. So what we're going to do is we're going to take our weighing paper, because we don't want to risk getting our magnesium strip contaminated, okay? And we're going to set our weighing paper on there, press the 0 button, place our magnesium strip on there, find the mass. In this case, I have 0.065. So I'm going to make sure to record that in the correct slot on my sheet here. And so for the unreacted magnesium ribbon, I'm 0.060. Okay. Now, the next thing we want to do is we want to determine the theoretical yield using the mass of the magnesium strip and the mole ratio from the balanced equation. And we're going to record our theoretical yield on our data table. So in order to do this, I need to find out what I'm starting with, and I just took the measurement, and the measurement was 0.060. Now we need to calculate our theoretical yield. In order to do this, the first thing we're going to need to do is have our balanced equation for the combustion of magnesium. Okay. In the combustion of magnesium, we have magnesium reacting with oxygen. Remember, oxygen is diatomic, so it has to be O2. And it yields magnesium oxide. Okay. Now in this case here on our left, we have magnesium, 1 magnesium. And on our right, we have 1 magnesium. So far everything looks good. On our left, we have 2 oxygens. On our right, we have 1 oxygen. So this creates a problem. The reaction is not balanced. So in order to balance the oxygens, I'm going to place a 2 in front of this magnesium oxide. And when I do that, now I have 2 oxygens on my left. 2 times 1, 2 oxygens on my right. Okay? However, when I put this 2 here, it doubled my magnesiums. So I'm going to need to put a 2 here in order to balance my magnesiums out. So 2 magnesiums there. Now let's double check our reaction. 2 magnesiums on the left, 2 magnesiums on the right. 1 times 2, 2 oxygens on the left. 2 times 1, 2 oxygens on the right. Okay. So we know that we do have a balanced equation, and so we're able to get our mole ratio from this balanced equation. Now, back to calculating our theoretical yield. For my particular piece of magnesium that I've weighed, it weighs 0.060 grams. So 0.060 grams magnesium metal will go in my top left corner. Now if I have grams of magnesium here The only thing that will cancel them out is grams of magnesium down here. So using my periodic table, I look at magnesium and it's 24.31. So 24.31 grams of magnesium. Now, the periodic table is always equal to 1 mole, so 1 mole of magnesium goes on top. Now, I need to convert my moles of magnesium into moles of magnesium oxide, and this is where I need my mole ratio. So moles of magnesium are currently on top, so I'm going to write mole of magnesium on the bottom, and I'll write mole of magnesium oxide on the top. Now, whenever we have moles over moles, we need to find the numbers that from the balanced equation to plug in there. So I have 2 moles of magnesium, so I'm going to put a 2 in front here. I have 2 moles of magnesium oxide, so I'm going to put a 2 here. Okay, finally, I need to convert my moles of magnesium oxide into grams of magnesium oxide. So 1 mole magnesium oxide goes here, and on top I'm going to have 40.31 grams of magnesium oxide on top. Okay, now we're going to go through and we're going to cancel what we can cancel out. So these grams of magnesium will cancel with these grams of magnesium, this mole of magnesium with this mole of magnesium oxide with this mole, and these 2's will also cancel. So now we have 0.060 times the 40.31 divided by 24.31, and this gives us a final answer of 0.099 grams. So 0.099 grams of magnesium oxide as my theoretical yield. Okay, so now I've got my evaporating dish as close as I can to the burner. I'm going to take my piece of magnesium strip. I'm going to go ahead and hold my magnesium strip with as little as possible being held by my forceps. Now the purpose of this is so that way the forceps don't cover up the magnesium and prevent it from burning. This way we have maximum burn. Okay, so, and again, don't stare at it. So I hold it there, I light it, and I'm going to hold it above. Again, watch what's happening, but not watching the flame. Note certain things that you see, and then carefully set it in there. Be as careful as you can, because if some ash falls out, that would be a source of error, which would show why you're producing a lower percent yield than what you normally or theoretically should get. Okay, so if you spill any, make sure that you note that. Now if you spill a lot, then you're going to need to cut off another piece of magnesium and do the burn over again, making sure if that does happen, making sure that you clean and dry your crucible. Again, crucible has to be dry, or the evaporating dish has to be dry, so that way it does not measure water weight. Now, this burnt fine. Now, I'm going to take my evaporating dish. If by chance you heated it up trying to burn the magnesium inside of it and the evaporating dish is hot, never ever put a hot evaporating dish on the scale. It won't measure correctly and it could possibly risk warping the plate on the scale. So be careful as far as that goes. Okay, I've got my ash on here. I'm going to set my scale with my product in there, and it measures 21.23 grams. So I'm going to record that on my sheet here. So 21.23 grams. Now, originally, my evaporating dish alone was 21.21, so that leaves me 0.02 grams as what I produced. Now, in my original calculation, I should have gotten 0.995 grams of magnesium, and I only received 0.02. So that doesn't look like I have a very good percent yield at this point in time. But let's go ahead and calculate that. So now we're going to calculate our percent yield, and the percent yield is going to be actual yield divided by theoretical yield times 100. Okay, well I actually got 0.02 grams. And what I calculated in theory would have been 0.995 grams times 100. And boy, it looks like it's close to 2%, which is very bad. Okay, so let's find out. 0.02 divided by 0.995 times 100, 2.01%. That is a very, very bad percent yield. And I don't know if you saw it when you were watching your observations, or the observations of me burning it, but there's a reason that this is so low, and I want to see if you could figure that out, and that's one of your questions that you're going to have on your lab. And other than that, this lab is done.